So good morning. My name is Dan Olajars, and this is my partner, Ben Waitzer. The focus of our project this term has been improving sustainability in Austin, Texas, a plan that we have dubbed an ostentatious future. So Austin really embodies a typical Southern American city. It's the state capital of Texas, located roughly in the geographic center of the state, has a population of about 1 million people, and it has a really diverse economy, a top-ranked university, vibrant downtown core, and has been identified by Forbes as America's next boomtown. And this is reflective in the fact that since the 1990s, it's seen a rapid influx of tech companies and gentrification of the downtown core. The city has developed plans under the Imagine Austin umbrella for the next 30 years, and these are 3 of the plans shown here. Austin really does have sustainability issues in all domains of infrastructure. Buildings are not particularly green. Transportation is heavily auto-dependent. Land use is not conducive to mixed-use development. Fossil fuels are used primarily for electricity. Water wastewater needs to be expanded, and a whole lot more that we're going to go through in this presentation. The result is high emissions and a not promising trend. In 2010, the city set this target for emissions, and thus far, it has not been met at all. In fact, the trend is looking even less promising than what is shown here. The vision is to be a complete community, and it's time to get Austin back on track, ostentatiously.
So inside Austin, the biggest energy use is residential buildings, and within that, the biggest energy use is cooling. They have 1,800 cooling degree days in Austin. Around 50% of the buildings in Austin are detached, and the average energy intensity is 77 kilowatt hours per meter squared. So based on this info, we conducted a review of available strategies for green buildings, and we came up with our plan. So our plan has different recommendations for low-rise versus high-rise buildings, but common to both is a smart energy monitoring system. This has a lot of benefits, including automatic temperature regulation and letting the utility cycle ACs during peak demand. It also provides data to users, which helps them maybe shift their behavior. Also common to all buildings is solar microgeneration. Austin is ideal for this. It has a warm, sunny climate. Solar microgeneration reduces line losses because it places the energy source directly at the home, and it also increases resilience. For low-rise buildings, we're also requiring all new buildings to have rainwater harvesting to take advantage of the large land area per person, and to have ductless heating and cooling, which we found to be more efficient on average. For high-rise buildings, we're mandating green roofs in all new construction to mitigate the urban heat island effect, and we're reducing parking requirements to have some benefits on the transportation infrastructure as well. So Austin is pretty unique. It's home to America's first green building code. We call it the Austin Energy Green Building Code. It's still updated today to meet best practices, and it's optimized for the local context. They also have an ordinance based on their building code that requires building audits whenever a house is sold. But our plan encourages people to expand that code to have regular energy audits for all houses. And we're also implementing policies that will demand any house found to have an above average energy use to lower the energy use to the average, or else pay a fine.
So the focus on our transportation policy is to really remove dependence on the automobile. Currently, Austin's auto mode share is well over 90%, which obviously isn't sustainable. We need synergy between the auto, transit, and active modes in order to create a sustainable transportation system. Transit mode share is currently at 4%, rather abysmal, and this is due to long bus headways and relatively limited access to higher modes of transit. There's BRT and commuter rail, but this only runs at peak hours. The cycle network is incomplete, despite a relatively active cycle culture, particularly around the university downtown, and our plan addresses both of these issues. On the transit side, we'll be implementing a light rail system. Light rail is preferred to other modes because it offers no local emissions, as the trains are fully electric, and our energy plan is using no fossil fuels. It's suitable for the density Austin has now and will be experiencing in the future. It has a strong image in that the transit vehicles travel on a dedicated right-of-way, and this will promote investment along transit corridors. And we see the transit investment that we're implementing as the single biggest reducer in BKTs from private vehicles. On the bicycle side, we hope to bring the lively bicycle culture that exists downtown to the rest of the city. We'll be implementing cycle tracks in the downtown core as well as residential areas so people have easy access to cycle infrastructure. And we'll be designing longer distance bicycle highways so people can make trips for longer distances. Austin's climate is relatively mild year-round, so we see cycling as a potential game changer as far as transportation goes in this city. And finally, we recognize the fact that despite the population growth that the city is going to achieve, it's still going to be relatively low density. And this means it's not going to be walkable everywhere. To supplement our transit system, our radical change is implementing a fleet of publicly owned shared autonomous electric vehicles. These will be subsidized by tolls on private vehicles and be paid for as a pay-per-use model, similar to how Uber or car share works now. We've seen some elasticity factors in literature and have determined that in the year 2050, 95 million VKTs will be by shared autonomous electric vehicles compared to 60 million by private autos, which we see as a huge change.
So Austin currently is dominated by single-family housing spread out all over the city, and our land use plan's main focus was to increase density everywhere. And our concept map gives an idea of this, with the orange being medium-density housing and the red being high-density housing. So you might notice we don't have any single-family housing left. We've abstined all single-family housing in the region to what we call medium density. And the characteristic of this zoning is that all new dwellings must be multifamily in some way, shape, or form. At a minimum, this means they must be duplexes or have accessory dwelling units in the back or in the basement. We're also requiring interspersed green space and commercial space in these zones, while keeping everything at a maximum of 5 stories. We also have stricter requirements for Austin's high density zones. Mostly, this is a minimum height requirement of 4 stories and wider building setbacks, as well as no parking minimums. So to illustrate our our design, we did a neighborhood design. We chose to do Colony Park, which is the biggest greenfield site left in Austin. It's kind of on the edge of the city. The plan focuses on creating small neighborhoods separated by open space. The open space protects natural habitats. It also includes regional park and wetlands and detention ponds to manage stormwater. Overall, the plan has 50% built-up area and 50% green space. The transportation plan in our neighborhood follows from our transportation design that Dan talked about. The main mode is LRTs, and you can see the big red dots. The neighborhood is served by 2 LRT stations, and most people are within a 15-minute walking distance to that. The secondary mode is shared autonomous vehicles for local trips and trips to the LRT stations. That's served by those orange strips, which are pickup and drop-off areas, as well as the big orange square, which is a central charging area for the cars. The third mode is biking, with the blue dotted lines being bike tracks, separated lanes, and we also have bike share stations dispersed in the neighborhood. Finally, the neighborhood will be walkable, not only on the sidewalks, but also with boardwalks and multi-use trails in between the open areas to connect the different neighborhoods.
Energy remains a big challenge in Austin right now. Currently, over 80% of energy is sourced from fossil fuels, mostly coal, but with some natural gas in the mix. In our sustainable plan, we see as wind and solar microgeneration being the main factors that will contribute to a sustainable energy system. We see 1,500 megawatts per each of these sources, with wind being implemented at a more industrial scale and solar at the microgeneration level, like Ben talked about earlier. In terms of emissions, there'll be no local emissions with wind and solar. However, when considering life cycle emissions, there will be 42 grams of CO2 equivalents per kilowatt hour, which is much better than the current 385 grams of CO2 per kilowatt hour. In terms of water, Austin's climate is very conducive to rainwater harvesting. They receive about 80 millimeters of rain per year, and we could use rainwater to offset the demand for non-potable water. On top of this, Austin already has a water reclamation service in which wastewater that is treated is pumped back into the system and can be purchased by residents and industries at a lower cost than potable water. Currently, only 3% of this water is actually pumped back into the system, but we see this as a huge potential for offsetting the demand of non-potable water. In our plan, 35% of demand can be met with a combination of rainwater harvesting and water reclamation, but more importantly, we see an opportunity to actually construct no new water treatment facilities despite a massive population growth. In terms of waste management, Austin's actually leading the United States as far as how aggressive they've been targeting waste diversion. They're on track to reach 90% diversion by 2050, and we will supplement their plan by adding a couple of different strategies. The first will be no single-use items in terms of consumer products and construction materials, which are the biggest source of non-recyclable waste in Austin. And finally, we will add free hazardous material pickups run by the city to make sure no hazardous waste actually get into landfill and are disposed of properly. We plan on increasing waste diversion to 95% compared to the 90% that is currently being achieved.
So when you take all the aspects of our design together, our plan actually leads to a 95% reduction in emissions from 2017 to 2050, which is pretty remarkable. The projected per capita emissions in 2050 are just half a ton per person, which is a lot less than what they are right now. The main source of the reductions come from taking the grid and making it renewable. So all of our calculations were done with the life cycle emissions for solar and wind. So you can imagine if you use their current methodology, which doesn't account for life cycles, it would be a lot less. The most dramatic reduction in emissions was in the transportation sector, and this came from banning all non-electric vehicles in 2050, as well as moving to a renewable grid. So everything is electric and everything is clean. This actually shows that right now, transportation actually doesn't use that much energy compared to the other sectors, but we use some of the most emission-intensive forms of energy for it, which is gasoline. It's pretty interesting. Residential building reductions come from both reducing demand as well as a cleaner supply. And it's interesting that even the non-residential buildings, even though we didn't actually design for that as part of the scope of this course, their reductions were really significant just from moving to a clean grid. We also have waste reductions, which stem from a large reduction in waste volume from our diversion plans. And when comparing our design to their targets, we actually beat their final 2050 target by half. So that is pretty encouraging. Their initial plan was to take that last 10% of emissions that they could reduce and use carbon offset. So we think that we can use that same plan for our 5% of leftover emissions, and so our plan can be considered carbon neutral. When looking at the urban metabolism of Austin, you can see in 2017, most of the major flows are pretty linear, but our plan manages to achieve some meaningful circuity, most notably in the water, as Daniel talked about, with 35% of water coming from reclamation and rainwater harvesting, and also in waste, with 95% diversion rate. So in conclusion, our aggressive and ostentatious plan not only improves emissions and the urban metabolism, but it also improves the daily quality of life holistically, as measured by the Sustainable Design Goals number 11. Our plan increases access to transit, it lowers land use per person, it reduces particulate matter, and it provides more open space, all things that are part of this goal. This is vital as more and more people move to cities, and for Austin especially, as it's primed to be a home to many climate refugees from Mexico as climate change progresses. So overall, there's very little doubt that our plan is anything but ostentatious.